Math 3, Unit 4, Section 1. So we're talking about equivalent rational expressions. What does equivalent mean? Equal to. Okay, for instance, if I had something like 3/6, what would be an equivalent fraction? 1/2, right? We would divide the top and the bottom by 3, right? What we're doing is we're dividing each of these by the same number, and we end up with 1/2. 3/6 and 1/2 are equivalent rational expressions, okay? So we're going to be reducing fractions. We're going to start up here. Okay, now, I like to kind of look at them as separate terms. Okay, so 28 and 7, can those be reduced? Yes. What can go into both of them? 7. So when we divide 7 by 7, we could make that a 1 if you want to, or you don't have to write it. Okay, and 28 divided by 7 is 4. Okay, now there are exponent rules that make this easier, but I'm just going to kind of talk through a couple things here real quick. Remember that a squared really means a times a. So the top there is really 4 times a times a. Okay, the bottom right now, we could write a 1, but we don't have to, but there's 5 a's. So just like we were able to reduce by 7, we can reduce by a's, correct? And so these a's will reduce, these a's reduce, and these are left over. Okay, and so my answer right now for this problem is 4 is on the top, or in the numerator, and then a to the third is in the denominator. Who remembers the exponent rule here for dividing? Okay, Alexis, will you tell me? It's okay. No, it's okay. Arturo. So yeah, like what I did, you can do that. The rule, though, is that if you're dividing, you can actually just subtract the exponents. And then it stays on the side with the larger number. Okay, and so 5 minus 2 is 3. And since 5 is bigger and it's in the denominator, the a to the third stays in the denominator. Does that make sense? Yeah? Okay. Now, another thing is that whenever you see something with adding or subtracting, these pieces are basically stuck together like glue, okay? The only time that you can reduce them is if you have something else in parentheses with an adding or subtracting that looks exactly the same. So right now in this problem, I cannot reduce anything, because anything, like I said, that's adding or subtracting is connected together, and you can't cancel it out unless you have something connected together that looks exactly the same. Does that make sense what I'm saying? Okay, but what do you notice on the top? Is there anything that could be factored out? A C, very good. And so if I factor out a C, what am I left with? A plus B, okay? And then in the denominator here, I have a C. Now, do you see now how the C isn't adding or subtracting with anything? That C is really saying C times the quantity of A plus B. And so when you have things that are multiplying, if they're the same, just like here we had 28 times A squared. Right here we have A times C, and then this is C times A plus the B. C times A plus B. So I can reduce these C's. They're not connected with a plus or a minus, okay? And so this answer ends up being A plus B over A. Now, could I reduce these A's? No, because this A and B, and maybe you want to put them in parentheses like that at times if you're going to get confused, but those are connected, and we can't reduce that unless it's exactly the same. Any questions? Okay, so going to this next problem, as they're written right now, could I reduce anything? No. Okay, but can I factor anything out of the top? So nothing, right? There's nothing that's like that I can factor out on in the numerator. Okay, but the denominator, could I factor out something?
Oh, yeah.
Very good. Okay, so I'm going to rewrite the numerator, 2n minus 3, over, and I'm going to factor out a 3 in the denominator. And when I do that, what am I left with? 2n minus 3. Now, do we notice anything that is the same? The 2n minus 3's. So we can go ahead and cancel those out because they are exactly the same. Now, on the top, there is nothing there. So anytime nothing is there, what can we go ahead and put? A 1. So that's the only time we need to put a 1 is when nothing else is there. And so we end up with 1/3 as our answer. Yes?
Why do you put the 1 there?
Well, why do we put it there? Because there's nothing else there. And when you're dividing, it's actually reducing to 1. For example, like if I had the number 5 divided by 5, and I reduce it, it doesn't become 0. 5 over 5 is 1 whole. And so anytime you're reducing and there's nothing left there, it's really a 1 that's left. We just normally don't write the 1. We only need to write it if that's the only thing that's there. Okay, is that make a little more sense? Okay. Yes.
Did you, on the bottom of the, okay, I always thought it says denominator.
Yes.
The bottom, okay. Did you take out the 3 on the 6 and 9?
Yes. So each of these had a 3 in common. So I brought the 3 in front, and when you divide each of these by 3, because that's what we're doing, we're taking out a GCF. So just like we did last unit when we looked for a GCF, we're looking for a GCF here first. And so the 3 is what I brought out, and when you reduce those, you're left with 2n minus 3. Okay, any other questions on this one? Okay. So the way I look at this one right now, there is nothing that can be reduced because this has a plus with it, so that's all connected together. It's not the same, so I can't reduce anything. So we want to check to see, is there a GCF? Can I factor anything out? So looking at the numbers first, is there a number that could be factored out? Good. 3 and a w squared. Very good. And so when we take that GCF out, what am I left with? Perfect. 2w plus 5 is correct. So again, we were just dividing each of these terms by 3w squared, which left us with this. Okay, and then my denominator is 24w to the 4th. So I can't cancel out the 2w plus 5, but in front here, because these are just multiplying and these are multiplying, we can reduce those. So can I reduce the 3 and the 24? Yes, so the 3 is going to cancel out and the 24 will become 8. Now what about with the w's? It turns into w squared, and where would it end up? The bottom. So if we go 4 minus 2, we get 2, and then because the 4 is bigger, that w squared is left on the bottom. Okay, so on the top, what am I left with? Good, and the denominator? Perfect. Okay, and then could I cancel the 2 and the 8? No. So again, when you notice a plus or a minus, put those in parentheses to remind yourself that those are stuck together like glue. And the only way that I can reduce those is either by factoring something out or if it is exactly the same. Okay? Bless you. So this 2 and this 8 cannot reduce because the 2w plus 5 is stuck together. Okay? All right, any other questions? All right, so this one, f over g of n, if f of n equals n squared plus 6n, and g of n equals 12 minus 4n minus n squared. How would I write this? Good. N squared plus 6n over 12 minus 4n minus n squared. Bless you. Now, in terms of factoring, this bottom one is not in descending order. Do you guys see that? Additionally, my squared term is a negative, and whenever you're factoring, like your highest exponent has to be positive. Okay? So I would rewrite this denominator, and you could do it in 2 steps or 1 step. For notes, I'm going to do it in 2 steps. Okay? So I'm going to rewrite this in descending order, making it negative n squared minus 4n plus 12. And then I'm going to go ahead, and the next step is I'm going to factor out a negative 1 to make that negative, this negative n squared, a positive. So if I take out a negative 1, if I factor out a negative 1, all it does is change every single sign. So this negative becomes a positive, this becomes a positive, and this becomes a negative. Bless you. Okay, and then the top, I still just have my n squared plus 6n. Okay, so what will I do next? What do you think? Good. On the top, as a GCF of an n. Everybody agree? So we take out an n, and what am I left with? N plus 6. Good. What will I do with these 3 terms? Yep, do your little factoring thing. Okay, so my multiplication number is what? Negative 12. My adding number is 4. Very good. 6 and negative 2 are the numbers that will work. Because there wasn't a coefficient in front, we can use our shortcut. Okay, and so the shortcut is that you're just going to have an n plus 6. So whatever this is, you cut that in half, and so I get an n plus 6, and then I get an n minus 2. You can go through it and do it the long way by, you know, changing this to your 6n minus 2n, and then you have your minus 12 and your n squared, and then do your grouping. So that also will work. Or you can do a shortcut. Yes?
How do you know when you can do a shortcut?
So you can do the shortcut anytime there isn't a coefficient in front of your squared term. So as long as the coefficient in front of your squared term is a 1, you're good. Okay?
It'll always be the...
So whatever this is, like, so let's just say that was n to the 4th. Then you would like split that in half, and you would do n squared at the front of each of them. Since it's n squared, we split it up, and it's each of them gets an n. Okay? All right, so now do we notice anything that's the same that can be reduced? N plus 6. And so here I'm left with an n, and the denominator I'm left with an n minus 2. I kept in parentheses to remind myself that I cannot cancel these n's because this other n right here is stuck with the minus 2. Okay? So anything that has an adding or subtracting is stuck together like glue, and it cannot be reduced unless it's exactly the same. Okay? So this is my answer. Questions? When you factor out a negative 1, you're just dividing every single term by a negative 1. So a negative divided by a negative makes a positive. A negative divided by a negative makes a positive. A positive divided by a negative makes a negative. Okay, any other questions on that one? All right. So next one, they're telling us you have this problem, and they're telling us that f of x equals 5x. I'm going to make this a little bit. Okay, so all we're doing is substituting in 5x for f of x. So how would I write that? Good. Very good. Now be careful of this because this is really 5x squared minus 9. So make sure that whole 5x part is being squared. So is there anything that I can take out, like factor out on the top? No. But on the bottom, the 5x is squared, and the 9, could I write that as a square?
Yes.
Yes, as what? 3 squared. So is this a difference of squares? Yes. So notice that they're both squares, and difference means minus, and so you can make your 2 sets of parentheses, and all you're doing is splitting up each of the squares. Yes? Oh, thank you. Just go ahead and sit on my desk. So we have 5x would be split up here, breaking up each of those squares. One gets a minus, one gets a plus, and then you're splitting up the 3 squared, so you get a 3 and a 3. And on the top, we still have a 5x plus 3. Do we notice anything that's the same? Good. And if nothing's left on top, what do we write? 1, and in the denominator is 5x minus 3. Any questions? Okay. Oops. I'm sorry, I'm going to make it small. There we go. All right, there we go. Can you see it now? Okay, next problem. So, is there anything I can factor in the numerator? Yes. What can I take out? 6. And I'm left with? C plus 2? Okay. Now, looking at this, will I be able to use the shortcut on this one? No, why not? Good, there's a coefficient in front, okay? So, 2 times 6 is 12, and then my adding number is 7. What numbers will work? Good, 4 and 3. So you could start making your list. You have 1 and 12, you have 2 and 6, and then you get to 3 and 4. So 3 and 4, add to be 7, and multiply to be 12. Are we okay with that? So whatever this middle term is, we're splitting this up, and so we get 3c and 4c. So whatever this is right here, that is what goes on those two terms. Okay? And so we have a plus 6 here, and we have our 2c squared. Then we factor by grouping. So we group those. What's the GCF of the first group? C. And I'm left with 2c plus 3. The second group, I can take out a what? A 2, and I'm left with? Okay. So instead of writing this right underneath here, I'm going to go up here and put it under here. So what will end up being my 2 parentheses? Good. 2c plus 3, because that was my new GCF. And then whatever was left in front, in this case it was the c plus 2, that goes in my second parenthesis. Is anything liked that I can reduce? Good. The c plus 2's. And so I end up with 6. Perfect. Can I reduce this? No. Put that in parentheses. Those are all stuck together. Okay? You cannot reduce anything with a plus or a minus unless it's exactly the same. Okay? That's my answer. Okay. Next one. What do we notice? Yes?
Could you take the cube root of 27y cubed plus 8?
When you are taking the cubed root, you're like solving. You should have an equal sign. You're solving for a variable. So there's no equal sign here, so all we can do is reduce and factor. But you did notice that all of these are cubes. So we can use our cube factoring, which we learned back in Unit 2. Okay? So 27 is what is a cube? Okay, 3 cubed. And 8 is what is a cube? 2 cubed. Okay, do you guys remember what the first parenthesis will look like?
Soap.
So soap goes with the second parenthesis. Well, actually, yeah. Right. Your first parenthesis is where you basically are just going to like eliminate the cubes. You once everything is written as a cube, you take those off, and you're left with 3y plus 2. 3y plus 2 is my first parenthesis. Your second parenthesis, is this big enough for you guys? Okay. The second parenthesis, there's multiple ways of doing it. Okay? So one way that I taught you guys was writing out like the first part where you went 3y times 3y times 3y. Because you have 3 of each of them. And then you'd have 2 times 2 times 2. And then you group them by 2's. Okay, I'm going to show you another way, in whichever way you like best is fine. And this gave you the 3 numbers. Remember that? So the other way that you can think about it is that this first term is this first term squared. So what is 3y squared? 9y squared. So notice the same as this. 3y times 3y, 9y squared. 3y, the whole quantity 3y squared, is 9y squared. The middle term, you multiply these two together, or the middle term is you multiply these two together, which is 6y. And then the last term is the last term squared, or 2 times 2, which is 4. And then you have to remember SOAP. So this sign was the same as the original problem. This sign is the opposite, and the last one is always positive. Okay. The denominator. How many terms are there?
4.
So anytime we have 4, we factor by grouping. What is the GCF of the first group? Y, and I'm left with?
3y plus 2.
Good. What's the GCF of the second group?
Negative 4.
-4, and we're left with?
3y plus 2.
Which means that my denominator over here is going to be what?
3y plus 2 times y minus 4.
Okay, is there anything that's like that we can? Good. And so my answer is 9y squared minus 6y plus 4 all over. That's it. Yes?
I remember you telling this, but I forgot. How did you find the first one? On the top?
The 3y plus 2?
Yeah.
Okay. So I'm going to go back to the 27. So we had, I'm just going to write it here to the side, okay? So we had 27y cubed plus 8, okay? So you need to write everything as cubes. 27 is 3 cubed, y cubed, and 8 is 2 cubed. And so all I do is end up, once they're all written as cubes, just cancel out each of the cubes, and then you have your 3y plus 2, which makes your first parenthesis. Okay? So just make sure that you write everything as cubes. Any other questions? Okay, moving to the back. This is not anything new. We just talked about this last unit. Okay? So if you look here, it says, what is the relationship between the numerator and the denominator? They're switched. Good. That works. Notice on this one, the 4 is negative, but on this one, the 4 is positive and the x is negative. So they've flipped. How could we make them so that they're the same? Yeah, we can factor out a -1. And it says, to determine this, substitute any number for x. So I'm like, well, let's put in a 5. Okay? So if I put in a 5 for x into these, 5 minus 4 is what? 1. And 4 minus 5 is -1. So to simplify the expression, you can factor -1 out of either the numerator or the denominator. So when they are opposite like this, we can factor out a -1 to make them the same and reduce. Now on this one, it says what's the relationship? Do you guys notice the relationship on this one? They're exactly the same, right? If we substitute in 5 again, 5 plus 4 is 9. 4 plus 5 is 9. To simplify this expression, you can, what? You can just reduce, really, right? And I'm going to put reduce because they are the same. So when you're adding, it doesn't matter the order that you add, right? And you could always rewrite this so it's x plus 4, and then it makes more sense to reduce them, if that works for you. Okay, so we're going to be practicing with this concept here. Starting with this first example, looking at our numerator, is there anything that I can factor out? Good, a 3 is correct. And then I'm left with what?
3a minus 5b.
2a minus 5b. Good. And if you need to, you can always go and write like dividing by 3 to like visually see what's happening. Okay, moving to the denominator. Good. We can factor out a 4. And then when we divide each of these by 4, we are left with what? Okay, and so what do you notice on this? They're the same, but the wrong terms are minus or negatives, right? And so what do we do for something like that? Factor out a -1. You can do the -1 with the top, and you could do the -1 with the bottom. But basically, when you are factoring out a -1, I'm just going to go to the bottom, but like I said, it doesn't matter. When you take that negative out, all you're doing is changing these signs. So the 5b becomes a negative, and because this one was a negative, it's going to become a positive. Are these like terms now? Do you see how the 2a's are positive and the 5b's are negative? If you want to rewrite it, you can, but since we know these are the same, we can go ahead and reduce and cancel them out. You don't have to rewrite it. And then your answer is just -3/4. When you have a negative out here, the negative can go at the top or the bottom. It doesn't really matter. Or it can be in front of just the whole term, whole fraction. All right, any questions? Okay, so this next one tells us that f of y is 16 minus y squared. Okay, and then the denominator is g of y to the 7th power. And so that is y minus 4 to the 7th power. You have a couple options here. You could just go ahead and factor differences of squares like it is right now if you wanted to. You might notice, wait, this y is in front and this y is at the end, and I'd rather just factor out a -1 and rewrite it to begin with. It will all end up working out the same. So does anybody have a preference? Factor out the -1 to begin with? Okay, so if I factor out a -1, I'm going to do it here to the top. What ends up happening here? 16 becomes a, and the y squared becomes a positive. So I'm going to go ahead and rewrite this one now. So I have a -1, parenthesis, and then I have y squared minus 16. And I still have this over y minus 4 to the 7th power. Anybody have questions on that so far? Yes?
Why would you factor out the -1? It's like whatever. You said it.
So notice on the denominator how this is y minus 4. In order for them to end up reducing, you're going to want the y in front and the 4 in the back. And so you could have factored at this point right here and did your differences of squares and got 4 minus y and 4 plus y. But these wouldn't match, and so you'd have to take out a -1 and end up switching it around. So all I was saying is you can do it either way. No matter what, you're going to end up having to factor out a -1. So if you noticed it at the beginning and you want to take it out at the beginning, you could. If you didn't notice and you did this and then you had to go back and do a -1 next, that's fine too. Either process works. Anybody else have questions? Okay. Oh, was there a question? No. Okay. So now this difference of squares, right? 16 is actually 4 squared. And so this will now factor, we solve our -1. And those are both written as squares now. So you split up your y's. One gets a minus, one gets a plus, and we split up our 4's. okay, over y minus 4 to the 7th power. So what can I do now? Very good. We can cancel out this y minus 4 here, and then this one's going to become what? 6, right? Because we are going 7 minus 1, which is 6, and it stays on the side of the bigger number. And so this final answer is -1, and then you have y plus 4 over y minus 4 to the 6th. There is no way of changing this one, right? Because both of them are pluses, and on here there's one plus and one minus. So even if we tried to distribute the negative through there, it wouldn't ever make anything that's the same. Make sense? Okay, so this is our answer. Okay, next one. What can I do? Good. Factor out a 4 from the top, and I'm left with what? 1 plus 2t. Good. Okay, can I use my shortcut on this one? Why not? 6 in front. Okay, so I multiply over. My multiplication number is what? My adding number is 1. So my numbers are going to end up being what? 2 and 3, and specifically a -2. So always double check. These do multiply and make a -6, and they will add and make a +1. So when I write this out, it's going to be 6t squared. Since this is a t, each of these are going to be a t. So I have -2t plus 3t minus 1. What is my GCF of the first group?
2t,
Very good, 2t, and I'm left with
3t minus 1.
3t minus 1. What's the GCF of the second group? Which is going to be 1. Good. And then we're left with 3t minus 1. And so my denominator ends up becoming what? Very good. 3t minus 1 and 2t plus 1. Okay. What do you notice about this one now? Yeah. Does it matter the order that you add things in? So do I need to rewrite these? No. I mean, you could if you want to, but that's kind of a waste of time. So it's adding, they're both the same, so those can reduce. And we're left with 4 over 3t minus 1. Any questions? Okay, last one. GCF. Do I need to go back? Or some of you not done writing? I'm sorry. Okay, what's the GCF? 3? 3. Anything else? 3p. Okay, good. 3p, and I'm left with 7 minus 4p. Good. Okay, denominator. What do we notice about this one? Is there a GCF? Good, difference of squares. So I'm going to rewrite them at each as squares. So 16 is 4 squared, p squared minus 7 squared. So we make, for some of you, you're having a hard time with this, so I just make the 2 parentheses. Do you see how at the front, each of them, there's a 4 squared? So we're splitting up the 4 in the front of each of them. Next, I have a p squared. So I'm splitting up a p there. Then you get to your sign. One gets a minus, one gets a plus. Then we're splitting up the 7s. Okay? Now, is there anything I can reduce? Very good. We have to take out a negative, right? Because these ones are opposites. Here the 4p's positive, here the 4p's negative. Here the 7's positive, here the 7's negative. We can take a negative out of the top or the bottom. It doesn't matter, but I'm going to take it out of the top. So that means I'm going to make the 3p a negative, and I change each of these signs. I'm factoring out a -1, which will make any positive a negative and any negative a positive. Are these the same now? Yes, because notice how the 4p's are positive and the 7's are negative. So these are the same. You could rewrite them if you want to, but I'm not going to waste my time. Those can cancel out, and so on the top we have a negative 3p, and the denominator we have 4p plus 7. Okay, any questions there?